Hello, everyone, and welcome to today's LinkedIn Live. My name is Sarah Barnes-Humphrey. I'm the founder and host of Let's Talk Supply Chain. And I am so excited to be collaborating once again with the team at Manhattan and Associates. Now, we've recorded 4 episodes together for Let's Talk Supply Chain, and we've talked about supply chain unification, planning, forecasting, and transportation management. And so I am really looking forward to another really fantastic discussion with them today. So a warm welcome to Jeff and Mandar, and I'm so excited for them to join me today. Now, today, we're going to be talking about demand forecasting. Now, our current supply chain landscape is defined by disruption, complexity, volatility, and everyone is trying to juggle that, trying to get a jump on the next disruption. But unfortunately, most of our traditional forecasting methods are no longer fit for purpose. Ongoing innovation is essential, but like so many other areas of supply chain, and in life, it really is a continuous journey, not a destination. There's not really a silver bullet solution right now, but the increasing demand for forecast accuracy is driving some incredible advancements across the industry. The rise in AI technologies like machine learning is driving real competitive advantage for businesses. And for those businesses that embrace the mindset of continuous improvement and evolving innovation, those small improvements are generating big results. But what happens when forecasting fails? Every year, companies across industries lose millions, sometimes even billions, due to inventory misalignment. Overstocked items lead to costly markdowns and waste, while understocked products result in missed sales and disappointed customers. So the big question that we're going to be answering today: could smarter AI-driven forecasting help prevent these losses before they happen? So if you're here in the audience, I want to hear from you. Put it in the comments. I want to know where you're tuning in from, and make sure to get your questions ready. Add those into the comments as well, so we can go get to those a little later on in the show. But before we do that, we need to get to know our guests for today. So welcome to the show, Jeff and Mandar. Jeff, I'm going to start with you. Can you introduce yourself? Tell us who you are and what you do.
Sure. Hello, everybody. My name is Jeff Beadle. I'm Senior Director with Manhattan. Been with Manhattan about 26 years, come up in 27 years this September, all in R&D, and focused on the science that goes into our products. So I lead the group that focuses on all of the mathematical optimization, as well as the data science, AI, and ML that goes into our products.
Yeah, and you can catch Jeff because you were on an episode of Let's Talk Supply Chain. So you can catch him over on our website as well, going into a little bit more depth as to what you do on a day-to-day basis, because it's fascinating. And of course, Mandar, welcome to the show. Tell us who you are, what you do, and give us a little bit of insight into Manhattan.
Sure. So Mandar Rahatekar, I'm Senior Director. I'm also with R&D. I've been with Manhattan for the last 4 years. I've been a supply chain practitioner before I joined Manhattan for the last 20 plus years. I lead the product design team. So my team is responsible for designing the features that are seen in the supply chain planning solution. As far as Manhattan is concerned, Manhattan provides supply chain software solutions end to end. So we have supply chain management solutions, which has warehouse management, labor and transportation management. And then we have our Omni suite of solutions, which is on the front of the house, so that has point of sale, store inventory management, and order management. And then last and definitely not the least, which is the focus of today's discussion, is supply chain planning, which includes demand forecasting, allocation, and replenishment.
Yeah, and you've been on the show as well. So I highly recommend you go and check out both of their episodes, because we go into a lot more depth. So let's start with some context and definitions so we're all on the same page. Jeff, I want to start with you. What does traditional forecasting look like versus AI or machine learning? What is the real difference?
Yeah, so traditional forecasting is usually done by statistical time series based models that use linear methods and require explicit design assumptions. Basically, they're kind of a predefined set of equations or formulation that then iterate over the data. And these usually range from general models like exponential smoothing or RIMA and a whole wide variety of variants of that, to more specialized time series models, let's say Holt-Winters or Crostons. Now, machine learning, on the other hand, are for the purpose of demand forecasting, are typically regression models that are built purely from data using complex algorithms and techniques that can autonomously detect, learn, and model nonlinear relationships of the variables and inputs and the target that you're trying to forecast without any of those predefined equations.
Awesome. Awesome. And I think forecasting has become, a lot more difficult. And so we want to talk about how we can take that traditional into the future. And let's dive a little bit deeper into machine learning. Talk to us about how machine learning algorithms detect those patterns, predict anomalies, and help to self-adjust. I mean, is that even a thing? I want to know.
Yes, yeah. I think that one of the things that, obviously, probably a lot of people are aware that machine learning um, requires a lot of data, and I'll get into that here in a second. But the thing that I think some people don't realize is machine learning, how it really fundamentally works is it's guided by mathematical optimization within the learning process. As it's working through all of the data, trying to model relationships within the data, it uses optimization. That's what provides a lot of the robustness and guarantees, if you will, that when you come out of it, along with some other techniques that you have to validate performance, it can lead to a very solid mathematical modeling representation of that predictive model. Getting back to the data, like I mentioned earlier, it learns directly from data, purely from data, right? So there's no pre-programmed or explicit programming in the learning algorithm. It has to build all that inference and understanding purely from data. And because of that, and the way that the algorithms are designed, they can be very complex, but not in a bad way. They can become as complex as they need to be based on the problem they're trying to solve. And these can use a variety of techniques and model structures like tree-based or graph-based or neural networks that many people hear about within deep learning and so forth. And these more complicated structures, along with the more advanced learning algorithms, can again capture these nuances and relationships amongst the data. Another key point of machine learning that helps it figure out these patterns and builds good predictive models is it has an innate built-in feature selection engineering process mechanism within it. And what that means is a feature, or is like a predictive variable or an input that goes into a model, it assesses and learns kind of its usefulness, if you will. And sometimes it can remove it, it can strengthen it, it can rely on it more, it can adapt it over time. And so it can grow and expand kind of its knowledge of how to more appropriately predict demand. And it has continuous learning. That's the one other thing I wanted to mention. It can continuously learn. As it gets more data, it can refine its understanding and adapt over time.
So I can really see, and that was actually one of the things I was going to ask you is as we feed it data, as we ask it more questions, can it then do better predictions? And when we talk about self-adjust, I guess it self-adjusts through the data that we're inputting into the system.
That's right. Yeah. Yeah, exactly. To point out, to connect that, to the self-adjusting piece. That's the continuous learning aspect, and this autonomous mechanism internally guided by just optimization that it can go through that process.
Awesome. So as I mentioned in the intro, forecasting innovation has been and continues to be a journey. I feel like we all want it to be a destination, but I think it's going to be that continuous learning, that journey. So can you talk to us through the shift from historical trend-based forecasting to AI-driven predictive intelligence? Like, what were the key factors driving that? Mandar, I'm going to start with you and go with, and then go to Jeff.
Sure, thanks. So to me, it's two things at a high level. One is consumer behavior. I mean, we all as consumers are shopping online more, which automatically means there is more data available. And for any machine learning model to be effective, it's not always true that more is better, but having access to more data can figure out which data points are usable, right? So the starting point is getting more data and then figuring out what is the right data set to impact forecast. So we just have more data available now. I mean, that's just the fact of it. I mean, all of us have seen this happen, which sometimes seems spooky, is you make a search for some topic and suddenly it shows up on all possible screens and searches. I mean, I'll mention a funny thing. Recently, me and my son were just chatting about how different ball players catch across the different across globe. So India, where I grew up, there is a certain way to catch a ball, and then he was telling me how he grew up. What's the technique? And lo and behold, next day I was on YouTube, and suddenly a search shows up about the physics of catching a ball. And that was mind blowing to me.
That is so creepy.
It is. It is creepy. At the same time, we are all now used to it, especially the next generation. They expect these things to happen, right? So point being, there is more data available. There are so many dots that get connected, and search results are just one example of it. The second one is just the technological capability. I mean, the amount of processing power that we now have compared to even just 4 or 5 years ago or a decade ago is exponentially growing. So a combination of more data and more processing power leads us to the ability of using these more enhanced statistical or machine learning models to provide better forecasts.
And I have a question before we go to Jeff, but because more data doesn't necessarily mean more good data.
Mm-hmm.
Right. So how are we making sure that we're putting in the correct data versus bad data? Or how are we sort of mitigating that?
Mandar, do you want me to?
Yeah, please go ahead.
Okay. Yeah, so that's a great question. And that is kind of more of I would say maybe a recent problem. At first we didn't have enough data. Then all of a sudden, we have all this data. Now we're like, well, hold on, we have a lot of data. How do we properly sift through it and understand what is most relevant and so forth? And I'll touch on that a little bit later, actually, because that's a great point. As we try to leverage more machine learning, especially in the context of external data, we have to be able to continuously assess the applicability and relevancy of data that we're considering.
Well, and I think it has to do also with trusting the data as well, because the people who are using it and are able to use it to predict some of those outcomes in the forecast and things like that, trust is a big issue. And knowing that the data that's going in, and I know we're going to talk about this a little bit later, but I just want to put it out there just in case anybody has any questions, wants to put that in the comments for a little bit later, is that trusting that data is a big key factor of that. So Jeff, I know I took us on a little bit of a different curve. Did you want to add anything to some of the key factors that are driving sort of that trend-based forecasting into the AI-driven predictive intelligence?
No, I was going to talk about computational power and kind of the advancement. So I think Mandar already touched on that, the data availability and really the diversity of data as well. And some of that data availability piece has really been accelerated and matured and hardened through a lot of digital transformation initiatives that companies have been doing, for the past 10 years or so. And many are still on that journey. That's very important. And to really help advance this further, because a lot of, you can have the most powerful machine learning algorithm and model, but if you only can give it limited data, it may not be any better than just, some standard native technique, because it just has limited information to work with.
Because as humans, we have a bit of an innate ability to overthink things. Do you think sometimes that limited data that we're actually putting into the system comes from us kind of overthinking what we're doing with the data and what we're sort of expecting from the outcomes? Because and where I'm coming from with this is kind of as humans, sometimes we have bias with the outcomes and things like that, which we might get into a little bit later. But that's why I'm asking the question.
Yeah, it does. When you have limited data, things become very ambiguous about what to do, about how to make predictions more appropriately, even for techniques that are designed to work with less data, like some of the time series, univariate, type time series models. When you don't have those additional factors in play, you can end up with misguided models. Either typically bias, though, comes through another mechanism than poor performance, like poor accuracy, kind of variability in your predictions. But you can get bias to that mechanism as well.
Interesting.
if you have limited information.
So let's talk about the external data for real-time forecasting, because really this is going to be a key part of this conversation, right? Because we all know that data is one of the biggest challenges when it comes to forecasting. Many businesses struggle with their internal data, like we were talking about before, but then you've also got this component of external data on top of that as well. So Jeff, you and I are going to talk a little bit about this. So let's start with how AI and machine learning helps to harness external data. How can we manage that through AI and machine learning, or how should we be using it?
Right. So machine learning has an innate capability to handle high dimensional data. Basically means that think of high dimensional like a spreadsheet, right? So if I have a tabular data set that I'm bringing into an ML model or a learning algorithm to learn from, high dimensional just basically means I could have hundreds of columns, right? That are input that I'm passing into the model for it to learn against. It's very powerful in that regard. It's designed to kind of handle that and be able to vet that out and weed through that and figure out what is the most meaningful set of features or variables in that data set. External data, how it can come into the ML model is just like that. Think of it as just like another extension or kind of concatenation or appending, an external data set. It could have multiple attributes, right? Typically does. It's not just a single value that you're bringing in with external data. Hopefully not. You want to be able to characterize that data as well so the model can learn from that. But it's just like, kind of bringing in another data set and bringing it together with your existing data that the model has already been learning from. So it's very, very much enabled and can handle that very well.
Absolutely. And so why is having access to this external data so important? Like, why is it really, I think you guys call it a game changer for businesses today.
Yeah.
We're all looking at ways for competitive advantage using not only our technology, but our supply chains as competitive advantage. So how does this feed into that?
Yeah, this brings, excuse me, this brings the demand planning and demand forecasting models closer to reality, right? So if we can bring in more external data, especially more real-time external data into the model, and so then at inference time when the model is being used for predictions, we get more real-time insights that can be shared into the model that it can use to predict with. So you're bringing that outside in demand planning mechanism and really strengthening that. And you want a modeling system that can be adaptive as well, because the other thing is, like some of your classic things you think from an external data perspective, like weather, or maybe local events, or like some classics. I think of like the automotive industry, like the Polk database, which is a registry by zip code of different cars and their year and make and so forth. And they can use that to figure out how to position inventory to service those kind of cars. Or for pharmaceutical, the flu projections from the CDC and the cough, cold and flu kind of product lines that they have to support. You want a system that can take that in and ingest that and figure out what parts of the overall data, the business data, it's most relevant to, so it can model and use it for that, because it's not going to be broadly applicable. That's part of the challenge with the external data, is you need to have a system that's adaptive enough to where some of that external data may only be very applicable for a small percentage or even 10%, but for that 10%, man, is it impactful.
Well, and I just want to give a shout out to Mackenzie. I see your question. We're going to get to that in just a little bit, because we want to go through some of these questions that I have around data before we get to that. And you're right. Data signals, we talk about weather all the time, especially in transportation, right? Because it can really impact routes.
Oh, yeah.
It can impact, which route we want to take. And it's not just weather. It's also when you think about trucking and you think about a route, the distance between some of the stops, right, that make a difference and can be an external data signal to help drive some of this accuracy that we're talking about. So how do you think that businesses can leverage those real-time insights for demand forecasting? Mandar, I'm going to bring you into the conversation to give us some insights on that.
So bringing in the data, there are many external factors, right? You have the standard indexes that we can bring it in, which is weather. You can talk about this data published by CDC, some of those data sets, but also when I think of external data, if I compare it to the historical uh, data sets that we're looking at, it's for that particular item location that I'm looking at, and how did this particular product sell at particular location historically. But there is also inherent external data within the organization, meaning even if I just look at item locations history for other items. So if I go to buy, go buy a particular soda, there may be other soda that influences, depending on whether it's a discount on similar items, that has an impact. To me, machine learning models are better at looking at those, I guess, product affinity impacts, right? I mean, if X sells better, or if the other product is at a discount, what's the impact on the product I'm trying to forecast? There is that external factor. Then if we expand that circle slightly broader to look at uh, beyond just the items and locations, and if I look at operations, right? And is it taking me longer to ship out, or is it taking me longer to bring the product in? There are these external factors that can be added into the forecasting to see, and part of it goes into the replenishment side of the equation, but still, am I having lead time delays? And we can enhance those kind of factors that eventually impact how much inventory I store in my system. So just that having the ability of having more factors brought in to the machine learning model to look at and consider can uh, enhance what the forecast accuracy could be. And then further we'll talk about how we can share the same plan across different organizations or departments within the company. We can come back to that. But to me, it starts with thinking of these weather and social media and those things which are a bit more intuitive or advertised, but there are also these external factors outside of the typical scope of data that we have access to.
Yeah, and I think about an example that I just shared this week on my show, Thoughts and Coffee, in respect to Chipotle and their avocados. They were talking about, instead of sourcing them in Mexico, they're going to look and source them in different countries within South America. And so if I think about this particular example, their forecasting is going to look a little bit different now that they're going to be sourcing from South America and shipping mostly ocean freight than shipping from Mexico, which is typically trucking as well, plus refrigerated and waste and all of that kind of stuff. So I wanted to throw out that example because I think that that's something that everybody can resonate with. Not that everybody goes to Chipotle and gets guacamole, but it's definitely something as an external data point that's going to affect the forecasting of buying avocados that they're going to have moving forward, right?
Yeah.
Yeah, and it's cross-functional. I mean, excuse me, what's going on? I got a frog in my throat. Demand forecasting it seems to be, is usually always coupled with inventory and inventory optimization, but it's more than that, right? Like you were touching on, from a transportation, logistics and distribution for this, changes that they're doing to their distribution network for avocados, and how do they appropriately forecast that, and bringing in the real-time insights into that as well, because now they're picking up potentially new sources, new business partners. They have to understand those lanes and the dynamics that can impact those lanes and so forth. And so, yeah, it's has a lot of broader impact besides just inventory optimization.
Well, and you can see why that external data is so important in that particular example. But Jeff, I want to ask you about some of the challenges in data integration, because we're also talking about that as well, because they're picking up new suppliers. And so they're going to have new data sets coming in, new external data. And I think it also depends with the data, how everybody categorizes it or labels it, and how well it's done, right? So how can businesses overcome challenges in that data integration and relevance around filtering?
Yeah, that's a big topic, and you probably have a session just on that.
Well, you only have 5 minutes. No,
so I'm going to focus more, and I think I speak to this probably a little bit later as well. But from a data model and forecast model perspective, especially for external data, you need to be able to characterize and prepare that external data. So you would do it obviously like you've done it before, for the original vendors. Now you got new vendors or new suppliers. You need to look for dependable correlational insights and relationships, right? Of any kind of external data that is associated to those new vendors or those new suppliers, as well as the whole kind of supply chain along that route in terms of the lane and so forth associated to that. If you have external data, characterize it, right? And so then you want to make sure it's clean, and I say appropriate, but what I mean by that is, well-defined and hopefully continuous and so forth, because ML, like I said, is purely data-driven, suffers probably the worst than anything from a garbage in, garbage out perspective. And so if you are trying to feed external data and it's sloppy, or it's it's got big omissions within it, or it's it's been miscleansed or something, it can lead to detrimental results in your ML model. So that's kind of the first part, is just preparing and assessing the external data that you have. And then you also need the ML model management team that you have. Sometimes they're maybe called ML ops teams, or the system that's being used for model management should itself also do its own assessment of relevancy and utility usefulness of that data for the models that it's serving. And it needs to do that continuously, doing experimentation and feedback and tests and so forth within the system, even potentially doing A/B testing internally, and have rollback strategies, because some of the external data may temporarily seem fine, but then it starts to fall off.
Right.
So there's a lot of I would say some complexities that come along with external data, and just even base data, but external data as well, that you have to have some degree of sophistication in the management system that you're using, either through people or through system.
Well, and I can see from what you're saying how that could potentially lead to costly errors, right? If we think about the title of this particular session, is your forecast lying to you? How can AI prevent some of those costly areas? We can see throughout this discussion so far how it can prevent costly errors, because when we don't have the right data that's going in and providing us with the right outcomes, or not being able to trust. I go back to what I was saying before, not trusting that data. We have to be able to trust the data. We have to be able to trust the outcomes. How do we know if a forecast or the data is lying to us?
Yeah. Well, that requires constant vigilance. And what we like to do is we have multiple versions and flavors of the model, if you will. And we're tracking all those continuously and against benchmarks. Like I mentioned earlier, with regards to the A/B testing, or kind of the experimentation that you're doing with these different external sets, don't just assume that after you've gone through the characterization and cleansing process, it seems like it's correlated, that it's going to work. The learning algorithm, modeling algorithm, and so forth needs to also do that assessment on top of that. That piece of it has to be involved, so that you have to be able to support the rollback and these alternate models that you may have to switch to if things start falling down and the forecast starts to fail, if you will. Because you can't pause the business and say, hold on, this has to happen continuously, right? Seamlessly. So you have to have some sophistication there in your system or your processes to handle that.
Mandar, do you have anything to add to
external data, but you got to have sophisticated systems.
Yeah, depending on if you're feeling optimistic or pessimistic, forecast can be a complete lie, right? Because forecast is forecast. If all of us could predict exactly what's going to happen in the future, we'd all be doing something else.
And getting lottery tickets.
Exactly. So forecasting is a lie, but with ML, it becomes less of a lie or more of a truth. And one of the lessons that Jeff has shared multiple times is, one of the key things is to determine whether a product is forecastable. If it's not forecastable, then we can have the best of models, and it's still it's going to be difficult. But with machine learning, definitely by improving accuracy, it's lying less. And constant vigilance. I don't think constant you can get away without constant vigilance to make sure that the forecast is staying close to reality. It's like driving a car. I mean, you cannot just full self-driving is still a pipe dream, right? So constant vigilance is key, and that will make sure that the forecast lies less or is more accurate.
More truthful, let's say that.
Huh?
Well, and I also think,
Yeah.
yeah. I also think, being aware of our own inherent bias when it comes to some of the outcomes that were being delivered from the data, from the forecast as well. Because if we look at it and we have some bias towards it, maybe it makes us look bad. Maybe we don't want to take it to leadership because, it's not something that we've thought about before or we've never done before. And we're just unsure about the outcome that it's presenting to us. I think that could also be part of the equation too, right, Jeff?
Absolutely. That's why you've got to have transparency and visibility, explainability of your models as well. It's very critical. You can't have black box, anymore. They don't get adopted. They get adopted at first, and then just like you said, users that are using the system can't explain or can't defend it. Their trust issues and so forth. And even if the model starts to go, awry or starts to go off a little bit, being able to explain why it is important, just like it was prior, like in maybe more the traditional forecasting sense, that it was a little more explainable because it was a little more transparent what was happening. That same degree of explainability has to be there now for the ML models too.
Mandar, did you have anything to add to that?
I'd add one aspect of the product itself, which is product lifecycle, which plays such a key factor into the forecast itself and the trends. Depending on what product we're looking at, if it's fast fashion, the trends are going to change, much rapidly than commodities or groceries that we buy. So forecasting has to be looked at with the lens of what is the product and what kind of life cycle it has, and which is one of the factors that would be in the machine learning model as well. But that's a key thing, is to be able to relate it to the type of product it is, the practical aspect of it.
Absolutely. Now, I want to let everybody know that we have put a link in the comments to an ebook about the evolution of demand forecasting. If you do want to take a look into this a little bit deeper and get some more information on that, because we're going to go into the next section, which is embracing a hybrid approach. Now, we kind of use this word hybrid across the board for a variety of different things. And so I want to know from both of you is how we take a hybrid approach and how that's key to Manhattan's vision and how it's been very effective for some of your customers. And just a quick reminder, if you have any questions, make sure to put them in the comments because we're going to get to those a little bit later on in the show. So Jeff, talk to us about the approach you use with UFM and why it's so unique. And maybe tell us what UFM stands for.
Yeah, so this is the unified forecasting method, what we call UFM.ai or UFM, depending on who you're talking to. But UFM AI is the hybrid model that essentially it's more than just a combination, but you can think of it as a combination of a sophisticated time series based model with machine learning. And to explain that, okay, what does that mean? Sophisticated, statistical time series model. Well, UFM.ai has evolved, if you will, from UFM. So the precursor, if you will, to that was the unified forecasting method, which is a composition of about 5 leading statistical time series models refactored and taken principal components out of those different methods and refactored into a single system of equations that continuously sense and evaluate different potential aspects of demand relative to intermittency, seasonality, trend, and transient aspects of those, as well as events that could happen in throughout there, and as well as the life cycle too. So you could have something that's intermittent and then starts to become more regular, or maybe it's seasonally lumpy, it's intermittent and sparse outside of season and so forth. UFM did that and did very well. It held up very well over the years. However, given that it's still a time series based model, it still had some challenges, right? So it was still modeling just the individual time series for the given SKU, let's say, that we're forecasting demand for. It couldn't leverage learning across hundreds of thousands, millions of other time series. It couldn't handle nonlinear type variables because it wasn't really a regressor based model. And because of these things, and because of that, then we couldn't bring in external data, if you will, to fold into that. I mean, there's ways that you can do it with time series models, but they're not very robust. So it needed an ML kind of boost, if you will. So that led to us looking into ML, and we've been researching this for multiple years. But the hybrid piece, where that comes from is ML itself. Maybe I'm jumping ahead here. I don't know. Steer me wrong if I'm wrong, or if I am. But the hybrid piece comes in to where machine learning, based on some of the things I mentioned earlier, is very powerful given all those concepts and topics we talked about. However, it's still constrained, if you will, even though I'm talking about it can be unconstrained with data, it's still constrained by the data you give it. So if information, demand information, or even external data is sparse or incomplete or misguided for certain aspects of the things that you're trying to forecast across your enterprise or across whatever aspect of your business you're trying to forecast for, it may have a misguided understanding or interpretation about how to forecast a given SKU at a given location or region or so forth, if it's missing some of that information. For other areas of the business, it may be fine and doing very well. And even that can happen from a temporal or a time perspective as well. Certain periods of time, the information could be good. Other periods, it could be questionable or sparse. So ML can still have challenges. There can also be, what I call going sideways, meaning that those features I talked about, those variables that go into the model, when the model's built, it understands kind of the distribution, if you will, of the dynamics of that variable and how it's associated to my target that I'm trying to forecast for. But that assumption can break down. So as you're moving, and using the model over time, some of those variables can drift, what we call, meaning that the assumption of the distribution, the model, the learning has changed. So you have to constantly keep reevaluating that. And that drift can vary based on how that model is being used across various product categories, different areas of the country. I'm probably going into too much detail on this, but
well, and I think
the problem is, yeah.
I think also what you're talking about too is bringing in sort of statistical models as well.
Yes,
and
that's
like
motivation.
benchmarking, right?
I'm painfully belaboring here. So like a good statistical time series model provides some of that demand modeling in a more simpler kind of construct, but it tends to be more reliable or robust. Especially if the ML model is relying on regressors to build its prediction, but some of that information is sparse or incomplete, it can really go off the rails, whereas a statistical time series model may not struggle as much.
Right.
So
and if you bring those both together, you also have a sort of benchmarking opportunity to also see where you land compared to other people.
Yes, that's correct. That's
Absolutely.
correct. So we wanted to, so the how we went about kind of doing this too, I can't get into too much of the detail, of course, how we did it, but conceptually what we've done in the ML model is we've brought in modeling constructs from that UFM, that precursor UFM model, into our ML model, as well as we tie them back together again at inference time. So there's things that happen within the ML model there's modeling aspects that came in from the demand model, the statistical model, the UFM model that are designed into our machine learning model. And then they're brought back together again with the base model to provide the final output. And so what we've seen over many times, different customer sets and so forth, the improvement is above and beyond what you did if you just had ML running by itself.
Right, because you have information or industry benchmarking information that you can then also take a look at, the information that you're being given, and also see what's happening across the industry, so you know where you stand. Right. And that makes a ton of sense. So I have a question for you though. Like, are there some practical steps that companies looking to embrace AI powered forecasting, this hybrid approach, that they can take? Like, what is it that they need to do before they can actually implement some of this technology?
Yeah, I think the biggest thing is data readiness, right?
Yeah. How are we still talking about this in 2025?
I know. Well, it's getting better. I will say that it's getting better, but it still happens when we meet with customers, and there are certain aspects that we want to be able to model, and we have that data, and then come to find out, oh well, we know we really don't have, or we have part of it, or aspects are missing, or some of it's not completely reliable. So, but it definitely is getting better. So I think more of the data readiness, and to really take advantage, to give ML and maximize its potential, if you will, is start capturing, assessing, preparing, and storing that data. Because often, we'll come in, it's like, oh yeah, we have the last 3 months of this. Well, that's probably not, I mean, it's helpful. We can start with that. But ideally, you would have more of that data. And so from an external data perspective too, if there's things that you have in-house that you think could be useful, analyze them, assess them, see if they seem like they're going to be useful, and start collecting it, storing it, put it into a data lake, which gets to another point is you may need to, I would say build, but I think most companies probably have something now, or some data infrastructure in place, but enhance it, or, augment it to store some of this data, as well as leverage that, because a lot of those tools and platforms help with managing, cleansing, assessing, that kind of stuff. The correlation, if you will, too, that you're looking for demand.
And if I may add to that, right? So there is, how do you know there is enough data? And at some point, there can be a statistical analysis to say, is this enough or not? But on the end user aspect of it, it's the trust but validate approach, or the constant vigilance aspect of it is, does this, meet my sanity test or gut feel? And it has to be a constant evaluation. I mean, trust will grow over a period of time. And then some things, can be run by the model, and some things have to be paid constant vigilance. One good example is when the product is new, and everybody who's in the planning domain knows this by practice, that when the product is new data trends are going to appear. So you have to hold its hand or monitor it till it becomes sustainable. So it's trust but validate, and then that will, some of that analysis will lead to going back and looking backwards and saying, do I have the right data? Do I have sufficient data? Do I have too much data? Am I correlating the wrong? Is the model correlating the wrong factors? So it's kind of and to use the term hybrid again, it's machine plus human, and that's the other hybrid aspect of this. Is it's going to be very difficult to let go of it completely, because one other dimension of this is the number of items that we all see, or number of products that are available. The assortment is so wide that you cannot just let it go. If we all were predicting just how much milk we are going to sell as an example, then it's easy. But there are so many different things, and it's trust and validate, and over a period of time, people will gain trust in the model itself, and they'll know when to stop trusting it and steer it again.
So historically, like, how far back should we have data? Can you tell us, or like, is that sort of on a case-by-case basis?
It's case by case. I know that's probably not the best answer you want, but often it's surprising. You may not need a whole lot of data for certain types of modeling of certain features, but typically for demand, you want at least a couple of years. But some of the features, if you get something new that you want to bring in, it doesn't mean that you have to wait 2 years. So if there's some new external set, if you have an appropriate ML management system, wink, 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 it can adopt that and warm that up, those newly added data elements, without having to wait and collect it, and so that it can match it up over 2 years or whatever. So it needs, the system itself needs to be adaptive so they can take new data, but the system should be smart enough to, be able to handle different lengths of data. But from a demand perspective, you definitely want at least several years of demand.
Well, and let's talk about unification, because I know that that's also a key to Manhattan's approach, and it's kind of something that you were alluding to just now. And Mandar, we've talked about this together on a podcast. So, just for everybody in the audience, what role does unified business planning play in all of this? I mean, I always say that collaboration is the future of business, and I think we're on the same page about that when you're talking about unification and bringing everything together on the same set of data.
Yeah, so one of the, I'd say paradigm shift that we are driving with supply chain planning being on the same platform as the execution systems is one plan for all. I mean, typically when we have different systems that are on different platforms that occasionally integrate with each other, they tend to, forecast differently. So as an example, if I have a separate warehouse management system, it's going to look when that system is planning for labor, or that team is planning for labor, they're going to try and look at their own historical labor trends, as opposed to with a unified setup. I now have one plan that it takes into account any promotions that marketing is planning or merchandising is planning, any deals that the planning side is seeing, which is going to increase the amount of inventory in the short term coming into the warehouse. That information, if is now because of unification available for the labor system or the warehouse team, then they're going off of one source of truth,
Right.
one number, as opposed to everybody trying to do their own thing, and then obviously that drives inefficiency. So if I go back all the way to forecasting in general, we improve accuracy, and then that accuracy is pushed through all the organizations, as opposed to everybody trying to do their own thing. And then with every time somebody's trying to forecast anything, be it demand or labor or anything else, it comes with its own set of inaccuracies. And over a period of time, it gets, or down the stream, it can get amplified. So with unification, one key benefit is if we invest the right resources to forecast as accurately as we can with the latest tools, then let's perpetuate that benefit to all the organizations, as opposed to just keep it limited to planning or
Well,
invention.
yeah, and we're breaking down the silos that traditionally have kept us, doing everything so transactional,
Yeah.
which is not any way to be proactive, right? We want to be proactive instead of reactive. And I think that unification, bringing everybody together, the data also will lead to some of the trusting of the data if you're all, using the same set.
Yeah, and trust is definitely one thing. It's also inefficiency, right? I mean, the downstream team may not be the best equipped team to forecast. So if planning is investing the time and resources, it reduces the burden on the other teams that are using that output, instead of having to do it on their own. So definitely, that's not the core competency or the core focus of execution systems, is to forecast. If planning is doing it, let more people get the benefit from it.
Absolutely. Now, I have one more question for you both, but we're not going to get to it just yet because I want you to get out your crystal balls. So we'll do that in just a minute. I want to get to some audience questions first because we've got quite a few good ones. Now, Mackenzie, I want to put it up on the screen, but I think it's going to take up all of Mandar. So I'm not going to do that. Mackenzie has a question to the same topic of trust in the data. So this is good timing. Can AI really outperform the knowledge of someone who's been forecasting for years? Like, if so, do you have any suggestions on how to convince team members to rely on the system? And this is a really big question, right? Because everybody they don't go into it with trust. You've got to build trust over time. It's like any sort of relationship. Who wants to take this one? Mandar, do you want to take this one?
I'll let Jeff go first.
Okay.
I think I touched a little bit on this, but I'll let
Jeff
take on this as well.
Great question, and kind of ties back to some of the things we talked about earlier. So how we approach it is you have a couple of versions of the forecasting model, if you will. So initially, for initial adoption, if you're new to this machine learning demand forecasting, you can have multiple versions. So one that's kind of the ground truth, if you will, or not the ground truth. One that's like the base forecasting mechanism that you can track. And the other one is, let's say, the UFMAI, which is the ML one. And it can be used in a passive mode, right? So it can be generating forecasts. You can see its performance measures over time. Look at the two to see how it's behaving. You can still go about making your adjustments if you need to and so forth, while you're seeing the performance of this new, AI model, and you can start getting trust from that regard. So that's a pretty big deal. So then they can switch. Okay, once I feel comfortable with how this is performing, then I can say, yeah, let me enable this. I want to proceed forward with this. The other thing too is the way that you go about serving prediction requests, a demand forecasting request for the model, is the model should be continuously evaluating itself against benchmarks. So at any point in time, if, like I said earlier, things go sideways, right, something's happened, you just don't keep cranking out bad forecasts, right? So you got to have that active monitoring that's happening very frequently to see if things are drifting. Do I need to retrain? Do I need to rebuild? Do I need to take the model offline? Do I need to swap it out with another model? Or just back up completely and let the base forecasting UFM model that I mentioned, more of the statistical time series model, continue forward for a while the system tries to repair or figure out what's going on with the external data or the ML model. So that mechanism is there within our system. And others could do something similar. Requires quite a bit of engineering to pull it off, but you can do that to where then there's confidence that way too, so that no matter what, that fallback strategy is always there. So you're not going to have completely crazy, runaway ML model.
Well, and I also talked about this with Kristen from Manhattan on a podcast episode that's coming up as well, in the fact that you roll out components at a time. So you're not rolling
Right.
out the complete system and overwhelming people so that
Right.
they can't trust it because certain things aren't working properly, or the way they haven't been trained properly or anything like that.
Yeah.
You want to roll it out in segments so that people can take the time to really understand what it can do for them and earn and build that trust.
Right.
I think is also what you were saying kind of with those pebbles.
Yep.
All right, we've got another question from the audience. Do you think forecasters will ever abandon the use of statistical models? I mean, we talked about hybrid being statistical models and machine learning, so we're kind of hoping not, I think, right? Or will they always play a role in planning? Who wants to take this one?
Well, I can give my 2 cents, and Jeff is probably better suited. But I think statistics is, it's part of ML. It's not that it's something else. So we will have statistical models, in my opinion. At the same time, there is this way to there is this KPI that we could add to understand how good the forecast is doing. So forecast value added, right? So if I compare my naive forecast, which can be take last 2 weeks of average or 4 weeks of average, which is really basic statistic, and compare that to what the machine learning model is giving, is it adding value or is it not adding value? So when the actual data comes in to compare and say, how did my ML model do versus how did my naive forecast do, which is, again, even if it's naive forecast, it's still statistics. So I don't think statistics is going away by any means. The different models that apply will obviously change. They'll get more sophisticated, but statistics is here to remain, or statistical models are here to stay, in my opinion.
Great. That's a great answer. One more before we get to the last one. So Alexia says, how is AI being used in Manhattan forecasts? Jeff?
Well, it's used within this hybrid model that I mentioned. So it's used in this infusion, if you will, of the two. It's not an if-then else. It's not a conditional type thing. It's then, let both run and then add them together. They're kind of infused, if you will, within the machine learning modeling part, and then again brought together again on the back end, basically to produce the unified output for the combined time series, the best of the time series aspects, if you will, and the best of the ML aspects. So that's how we use machine learning within our UFM AI. Now, in general, for Manhattan, we use machine learning across a variety of different things. So those are, it's a big question, but for AI, for demand forecasting, that's the core forecasting model that we have.
Awesome. Thank you for that. That's a great question. I have one more question. We've probably only got about 1 minute for the answer. Since external data can be unstructured, incomplete, have anomalies, and can change frequently, how does Manhattan separate what matters from what doesn't when you're pulling in outside data to improve forecasts? That's a really great question from the audience. Jeff, you want to take this one?
Yeah. It's similar to the contract I described earlier that when we bring external data in, we fully vet it out. We don't trust it, basically. So we run internally within the system, I would say multiple experiments, and then we test it over time. And we can even, kind of, let's say, downgrade or upgrade some of the data that's in that external data set based on its relevancy and impact. But we assess it to make sure it doesn't damage or degrade what our baseline forecast would be if we didn't include the external data. And then we continuously do that. Continuously over time. So
great. And I want to let everybody know, not only have we linked to an ebook, we've also linked to a white paper for more information. It's called Beyond Traditional Forecasting, the Hybrid AI Advantage. If you want to learn more and get some more information after this discussion, make sure you go to the comments, grab that link, and go check out the ebook and the white paper. So Jeff, last question before we go. Do you have any predictions around emerging technologies that are going to be shaping the future of predictive analytics in the coming year? I'm asking you to get out a crystal ball. Hopefully you can answer this for us.
Oh yeah. This is pretty, I think in my mind, pretty straightforward. There's a few things, and most of it is centered around generative AI and some of the, I would say, emerging technologies leveraging that, AI agents. And kind of the next step in the evolution of that is agentic AI, where it's multi-agent systems, orchestrated to achieve goal-driven tasks, goals set by you, and operating within your guardrails that you've defined, but executing things on your behalf. So there's two benefits. One, it can strengthen predictive capabilities, the generative AI aspect, in terms of how it can model textual or even images into helping to produce, like, a forecast for a brand new novel item that you never had before, but you have an image of it, right? So it can help use that. It can use that to help in the predictive modeling. And then the other part is from the more agentic side or AI agent side of it is to help manage, monitor, optimize demand planning and demand forecasting processes, and give you the ability to have a conversation with your data. So lots of cool things coming there.
Mandar, any last comments on that?
No, I'll just say that will be pretty cool to chat with data. Looking forward to that one.
Well, that, and I think we need a dictionary for all the acronyms and words that are coming up around AI. Because you just used another one that I don't know if I've even heard of that one yet.
Oh, yeah.
Agentic? Was it agentic?
Fresh agentic, yes.
I've heard of AI agents, but now you've added another one to my vocabulary. Thank you, Jeff.
Good.
My interpretation of that really is I happen to see some visual on LinkedIn somewhere, but it's agentic AI is really a supervisor agent that can figure out stuff from different agents and give you an answer.
So maybe that's what we're going to.
It's autonomous. That's the biggest thing. You can do that autonomously.
So
it's like an auto approve, auto execute kind of capability that's acting on your behalf continuously, right? So, but yeah.
So many cool things coming up. Maybe we have to put together a graphic that showcases all the different AI acronyms and descriptions and words that we're using so we can all keep on top of it. Well, that's all the time we have for today. Thank you so much for all of you who joined us, put in the comments, told us where you were joining from. A big thank you to Jeff and Mandar for another incredible, insightful discussion. You guys always deliver. And another reminder, friendly reminder, to go and grab the link to the ebook and the white paper that we've put in the comments so that you can learn more. Plus, you can learn more about how your business can move beyond traditional forecasting and leverage a hybrid AI advantage. Head over to manh.com/SCP, which should be scrolling along the bottom of the screen right now as well. Thank you so much for everybody who joined us, and I'll see you all again soon. Thanks, Jeff and Mandar, for joining us today.
Thanks, Sarah. Thanks, everyone.
Thank you, Sarah.
Bye, everyone.
Bye, everybody.